when we're given a percentage. Okay, area under the normal curve responding to negative 0.3 and 1.6. I'm going to go ahead and do my z-score for both of these. So negative 0. I'm sorry, I can't do the z-score because I don't know my mean and standard deviation. I'm going to look both of these up in the table to find their percentage. So I'm going to look up negative 0.3 in my table. Negative 0.3 is 0.3821, and I'm going to look up 1.6 in my table. 1.6 is 0.8554, and I'm going to go ahead and subtract those. So 0.8554 minus 0.3821. Oops. Make sure you write your decimals in your calculator, otherwise life is going to be hard. Which is about 47.33. Again, there's a slight variation depending on how much you're rounding by. Oh, and I looked at the wrong one. 0.16 is 9. I'm sorry, guys. I looked at 0.06. No wonder we got a funky answer. 0.9452. Ooh, Miss Hawes, a little rough day today. Minus 0.38. Again, I'm just subtracting those two because I want to know the difference. So that should be 56.3, which ends up being a nice number. So my apologies. That is incorrect. C is our correct answer. So make sure you are really paying attention on that z-table. I'm looking on my computer. You're actually going to have a physical copy that you can circle and make sure you're looking at correctly. The wait time at your local McDonald's varies according to a normal distribution with a mean of 7 and a standard deviation of 1.35 minutes. Approximately what proportion of wait times are over 9 minutes? Okay, now remember, when we're looking at z-score, that tells us everything below this. In this problem, they want to know above. When is it over 9? Okay, so you're going to have to subtract from 1 when you get your answer. So 9 minus 7 divided by 1.35 is going to be 1.48. Okay, and it wants a percentage, so I'm going to look up 1.48 in my chart here, which is 0.9306. So that's 93%, so 100 minus, or I could do 1 minus 0.9306, and that's going to be 0.069. They're not putting it in a percentage. They were leaving it as the decimal, so you can leave it as that. Okay. All right, this one got a little cut off. So we have women's heights are normally distributed with a mean of 63.7 inches and a standard deviation of 2.9. The United States Air Force will reject female pilots that are in the top 10% of all women and the bottom 5% due to cockpit restrictions. Which of the following intervals of heights are accepted? Okay, so we're looking at the top 10%, which is really 90%, because again, we look at what's below, and the bottom 5%. Okay, and we know our mean is 63.7 and our standard deviation is 2.9. Okay, so we need to find our x value, or our z value. I'm sorry, we don't know what x is. Okay, so I'm going to look up 90% in my z table. 90%, if I go in the right direction here. 0.89. Okay, so we're going to go 1.29. Okay. And our bottom 5%, which is 0.05, we're going to go ahead and say that's going to be negative 1.64. Okay, and I'd solve that. So I'm going to multiply both sides by 2.9. So we're going to have 1.29 times 2.9. It's going to be 3.741. It's going to equal x plus 63 plus 2.7. So I'm going to subtract. I'm sorry, what is happening here? Oh, I'm sorry, this was a minus and I wrote a plus. There we go. I'm going to add 63. I was going to get a negative number, which is why I was a little worried. So 67.441. And I'm going to do the same thing with the negative 1.64. I'm going to times that by 2.9, and then I'm going to add 63.7 to that, and that's going to be 58.944. And I'm going to look to that one, and that looks to be about C. Okay. Mrs. G's newborn girl sleeps approximately 20.1 hours per day. The newborns are normally distributed with a standard deviation of 0.8. If you know her daughter's percentiles for sleep, what is the mean sleep? Okay, so we know she's sleeping for 20.1 hours per day. We don't know the mean. We do know the standard deviation. We also know she's in the 67th percentile. I'm going to find 0.6 in my z table. So 0.6 in my z table is 0.44. Okay, now I'm going to solve just like I did on the previous one. Again, remember when you have a percentile, that's not a z-score. You have to find your z-score using the percentile, which I changed it as 0.67. Okay, so I'm going to do 0.44 times 0.8, okay, which is going to be 0.352 equals 20.1 negative minus x. I'm going to minus 20.1, which is going to be negative 19.75 equals negative x, so then it becomes positive, so therefore I know the answer is A. All right, let me just read it off of this. Okay, so your favorite bag of candy says that you should have 8 ounces of candy in the bag. You weigh the contents and you find that you only have 7.8. You log onto the candy's website and strongly worded email and see that they have a disclaimer that the weights of the bag will vary to a normal distribution with a weight of 0.8 ounces and a standard deviation of 0.25. Which of the following is an appropriate conclusion based on the information? So it is right that 7.8 is still a reasonable weight of your candy bag since it falls 0.8 standard deviations below our mean. Okay, so it is completely normal that if we take away 0.25 ounces from that, that's gonna still be within that range of the points, the 7.8. Okay, so we wouldn't say that's not reasonable. 0.2 is within range. Okay. Moving right along. All right, normally distributed. Again, it says at a local pumpkin patch, the mean weight of pumpkins is 12 pounds and the standard deviation is 1.3. Label our normal distribution curve. So our mean is 12, and then we're going to keep adding 1.3 every distribution this direction. So 13.3 plus 1.3 is 14.6 plus 1.3 is going to be 15.9. And then we're going to subtract 1.3 the other direction, so 10.7. And 9.4, and there's an invisible line there that I just missed when I was drawing. It goes 8.1. Okay, so it says 99.7% of pumpkins weigh between. Well, I know 99.7% is between our numbers here, our last little pegs. Okay, so I know that's between 8.1 and 15.9. Okay, 34% of pumpkins weigh less than 12, so I'm looking at something less than 12. I know 34% is in this area, so it's going to be but more than 10.7. 0.15% of pumpkins weigh more than how many pounds? Again, this is my 0.15. Again, I strongly recommend having that written on your note card for this, so more than 15.9. 47.5% of pumpkins weigh more than blank, but less than 12 pounds. So less than 12 pounds. This is my 34%, and then this is 13.5, which adds up to 47.5. So it is more than 9.4, but less than 12. Okay. And again, I think labeling each of those with your percentages is super helpful. So definitely get that down. What percent of pumpkins weigh between 9 and 11 pounds? Well, 9 and 11 isn't a pretty number on my empirical rule, so I have to do my z-score. So I know that I have 9 minus my mean, which is 12, all over my standard deviation, which is 1.3. Oops, sorry, that shouldn't have it out there. And then 11 minus 12 over 1.3. So we're going to calculate all those out, 1.3. So 9 minus 12 divided by 1.3 is going to give me negative 2.31. And 11 minus 12 divided by 1.3 is going to give me negative 0.76 or 77 actually. Okay. And then I would go ahead and find that on the outside of my z table. So I have both negatives. So negative 2.31 is going to be 0.0104. And negative 7.7, what was your 1, 2, 3, 4, 5, 6, 7, 2.2.202. Okay, and then we would subtract those from each other because we want what's between them. And that gives me, when I subtract these two numbers, 0.2102 if I move my decimal 2, so that's 21.02%. Okay. Because it did say what percent of pumpkins. Okay. Weighs at least 15 pounds. We're going to do 15 minus 12 divided by 1.3. We'll look that up. That'll be our answer. It says what percent of pumpkins, weigh at least 15 pounds. Let's calculate this out. So 15 minus 12 divided by 1.3. So they are looking at the above 15. So this would be 2.31. So I'd look up 2.31 in my table, which I think we've already done once. So that's 0.9898. So we're going to do 1 minus 0.9898, So that would be 0.0102. So 1.02% of pumpkins are weigh at least 15 pounds. Yeah, so that's above 15 pounds. So very small number, weigh above 15 pounds. Okay. What percent of pumpkins are 10 pounds or lighter? Again, we're going to do 10 minus 12 divided by 1.3. Find the Z number, look it up in the Z table. That's the answer because we want the less than 10. So that's what the Z-score tells us. All right. In a perfectly normal distribution, which of the following are true? The mean and the median are equal. 50% of the data is below the mean. That is definitely true. The data value is 1.5 standard deviations below the mean is an outlier. I believe that this is 1 and 2 only, but I can't erase. Let me see here. What page am I on here? Sorry guys, I have to remember some of this stuff too. And I'm trying to remember where all my answers are. Okay. I believe B is correct. Yes. Okay. I was right. So B is correct there. Okay. Because the 1.5 standard deviations below the mean is an outlier. It would depend on what exactly is happening. Like it's one. Anyways, it's B. Sorry, guys. I'm not perfect at stats. All right, so the mean of the set of data is 40 pounds and the standard deviation is 8. What is the Z-score of an object with 30 pounds? Again, we're going to do 30 minus 40 all over 8. So 30 minus 40 is 10 divided by 8 would be negative 1.25. So D would be our correct answer. The variable X follows normal distribution with a mean of 20 and a standard deviation of 5. According to the empirical rule, the min is 68% of the values fall between what two things? So you could also do this as a picture, right? So you could be like, okay, I'm going to subtract 5. I'm going to add 5. So that would be 15 and 25. We wouldn't have to use the Z-score for that one. All right. Mrs. G's first daughter was 4.85 kilograms when she was born. The weight of the newborn baby follows a normal distribution with a mean of 3.54. And that's standard deviation. Okay, so with her firstborn, we know she was 4.85 when she was born, minus the mean all over the standard deviation. So her second child, okay, newborn males follow normal distribution with a mean of 3.78 and a standard deviation of 2.96. What does her newborn baby boy have to weigh to match the newborn baby's Z-score? Okay, so first we have to calculate the baby girl's Z-score. So 4.85 minus 3.54 divided by 2.43. So that is 0.54. So we're going to just set that equal to 0.54 over here. So we're going to do 0.54 times 2.96, adding 3.78. So that would mean the weight needs to be 5.38 kilograms. A statistics teacher grades using Z-scores. How kind. On the second major exam of the marking period, a student received a Z-score of negative 1.3. What is the correct interpretation of this grade? The student's grade went down 1.3 points from the first exam. No, because a Z-score has nothing to do with the specific points. Student's grade went down 1.3 points more than the average grade went down on the first exam. Okay. Student scored 1.3 standard deviations lower on the second exam than the first. We can't compare them because we're not talking about the two different exams. They didn't tell me anything about the first exam. A student scored 1.3 standard deviations lower on the second exam than the class average on the first exam. Again, we're not comparing the two, okay? It's just like on the second exam, that's what's happening. The student scored 1.3 standard deviations lower on the second exam than the class average on the second exam. Bam. Again, the B can't because we're comparing to the first exam. So they didn't tell us anything about what happened on the first exam. They just said this is the second exam. So I can't compare the two because I don't know what happened. So it has to be comparing their second exam to the other class's second exam. Okay, a popular movie theater chain collects data on how much their patrons spend on concession stands. The data is approximately normally distributed with a mean of 20.56 and a standard deviation of 4.55. Graph the distribution, going out 3 standard deviations on either side. Okay, I think you guys can do this. We add 4.5 3 times and we subtract 4.55 3 times this way. Okay, but we're going to need it to do it, so I guess we'll do it together. So 20.56 plus 4.55 is 2511 plus 4.55 is 29.66, plus 4.55 is 34.21, and then I'm going to do the subtraction. 20.56 minus 4.55 is 16.01, and then subtract 4.55 is 11.46, and subtract 4.55 is going to be 6.91. Okay, so what percent are between 4.6 and 29.6? So that is going to be our 95%. What percent spend above 2511? So that would be my 13.5% plus the 2.35 plus my 0.15. So that would be 16%. What percent spend under 20.56? That's 50% because that's the median, or the mean, I'm sorry. What percent spend between 6.91 and 2511? Okay, so that would be our 2.35 plus 13.5, if I can write that in the calculator correctly, plus the 34 twice, and that would be 83.85. And again, you guys can color that. I think you're capable of, once you have it drawn up here, just shading the right amount on each spot, okay? All right. Unit 5, which is our probability stuff. So which of the following is a correct statement? An event is certain to happen if it has a probability of 1. Certain not to happen, that's false because that would be 0. Probabilities are numbers whose values can be anywhere between -1 and 1. That is true. The total probabilities of all values of a sample space must add up to 1. Okay. Can be any number between -1 and 1. Okay. Total probabilities of all values in a sample space must add up to 1. The law of averages tells me that if my first 10 flips of coins are heads, then the next flip has a higher of being a tail. False. Okay. Probabilities are numbers whose values can be any number between -1 and 1. I'm sorry. Probabilities are between 0 and 1. So that is false information. C. See, even math teachers sometimes have trouble. Okay, so an event occurs, probability of A is 0.2 and probability of B is 0.8, and it says they are mutually exclusive, so there's no overlap. 0.2 and 0.8 already add up to 100%, so I know there's nothing extra happening. Either A happens or B happens, okay? So A or B has a chance of 1, that is true. A and B equals 1, false. I can't have A and B happening at the same time because they are mutually exclusive. A or B 0.16 doesn't even make sense. A and B 0.16, again, doesn't make sense because I would have to add those up, and 0.2 plus 0.8 is not 0.16, so they're just trying to confuse you. There are 5 vowels in the alphabet. There are 26 letters in the alphabet. What is the probability of randomly choosing a letter that is not a vowel? Okay, well, it's out of 26, and there would be 21, if I subtract 5 from 26, that are not vowels, so 21 out of 26. What is the probability if you select a single student from these classes if they have an A or AP? So my AP is that there are 14 students, and then my A has 12 students, but I don't want to double count that 4, so I'm just going to add that 8. Okay, 14 plus 8 is going to be 22, and then I would divide that by my total, which is 40. 22 divided by 40 is 55%, or 0.55. At Mathville High School, 60% of students have internet access, 30% have Google Chromebooks, and 20% have both. The proportion of students that have neither Google Classroom or internet. So I always like to draw a Venn diagram for this. So both is 20%. The whole of Google is 30, so then my left over here is 10%. The whole of students who have internet access is 60, so my leftover is 40. 40 plus 20 plus 10 would be 60, 70%, so that means 30% are outside of here, and that means my answer is also 30% because 30% don't have a computer or internet access, because we'd want to make sure that all 3 of those are counted there. All right, probability of B. So I changed these up from your actual test just so you could get some extra practice with this because it was easy to change. Probability of B, which is bachelor's degree. Okay, so there are 742 people with a bachelor's degree out of 1,720 people total. So 742 divided by 1,720 is going to give us 43%. Probability of being a female is 950. Whoops. Out of 1,720. 950 divided by 1720 is going to give us a whopping 55%. F and B, so that means both have to be true. That's 408 students out of 1720. So 408 divided by 1720 is going to give me a whopping 24%. M or D, again, that means all my males, okay, 770, or they have a doctorate, okay? Again, we don't want to double up on that 94, so I'm just going to add in my extra 117. So 117 or 116, I can't read. 116 plus 770 is going to give me a whopping 886 out of my 1720, because that's the total number of students, or total number of people, I'm sorry. 52% if I run correctly. Okay. All right, hopefully that gives you a good idea of some of those things on your exam. If you did not receive an email from me about a note card, feel free to email me and I can send that to you. Have a great day. Bye.